In this video, we're going to complete example 1. For the activity network at right, what are the float times for each activity? So we need to calculate the float times for every activity that we can see here. Now, we don't have a lot of space here to write down our float times. So I'm going to write a little reference here saying that all float times are in brackets next to each activity. So we'll start with activity A. And in order to find the float time, we need to look at the vertex at right for the latest finishing time and the vertex at left for the earliest start time. So to find the float time, we take the latest finishing time, 6, subtract the duration of the activity, 5, and then subtract the earliest start time, 0. So we're going 6 minus 5 minus 0, which equals 1. So we have a float time of 1 for activity A. Now, for convenience sake, let's just say that this is 1 hour. So activity A can be delayed for only 1 hour. All right, let's look at activity B now. Activity B has a latest finishing time of 3 and an earliest start time of 0. So we don't need to write the working out each time. We can just work it out in our head. 3 minus the duration of the activity, 3 minus 0 gives us a float time of 0. So activity B is a critical activity, meaning it cannot be delayed at all. We'll now move on to activity C, and I'm going to stop highlighting the numbers each time. We really don't need to do that. Looking at activity C, our latest finishing time is 10. So we go 10 minus 4 minus 3, which gives us a float time of 3. So activity C has a reasonably long float time. It can be delayed for quite a while. Looking now at activity D, it has a latest finishing time of 9. 9 minus 6 minus 3 gives us a float time of 0. So activity D is a critical activity. It cannot be delayed. All right, let's look at the dummy activity now. Do we really need to calculate the float time for the dummy activity? I mean, it's not a real activity. So why do we care whether we can delay an imaginary activity? Well, there might be a couple of uses for it. For instance, if I want to move from activity A through to activity F, is there some sort of a delay that I can have between these two activities? And another reason that it might come in handy, we mentioned earlier about critical activities, and we're going to use these to answer question B to find what is known as a critical path. So I'm quite interested to know, is the dummy activity a critical activity? Anyway, let's calculate the float time here. 10 minus 0 minus 5 gives us a float time of 5. So we'll calculate the float time for the dummy activity, but we might not use it, and that's okay. So we'll look at activity E now. It has a latest finishing time of 13. 13 minus 7 minus 5 gives us a float time of 1. So it can be delayed by only 1 hour. Activity F has a latest finishing time of 13. 13 minus 3 minus 7 gives us a float time of 3. And activity G has a latest finishing time of 13. 13 minus 4 minus 9 gives us 0. So activity G is a critical activity. And finally, activity H, which has a latest finishing time of 15. 15 minus 2 minus 13 gives us a float time of 0. So this is another critical activity. Now moving on to question B, it's asking for what is known as the critical path of the project. And if you remember that a critical activity has a float time of 0, the critical path follows all activities from start to finish where all float times are 0. So if I was to color this path in red, it would be through activities B, D, G, then H. Since all of these activities have a float time of 0 and are critical activities. So to write this down, we're going to write B, then D, then G, then H, like so, under question B. And then for question C, it says, what is the minimum time required to finish the project? This is really easy. You just need to look at the numbers on the finish vertex, which is 15. So we'll write it down as 15. It never said anything about whether it was hours or minutes, so we don't need to write anything next to that. If you really want to, you can write 15 units because you don't know what the units are. There is another method you can use to find the minimum time required to finish the project. If you follow the critical path and add up the duration of each activity, you'll get 15 as well. 3 plus 6 is 9, 9 plus 4 is 13, and 13 plus 2 is 15. Anyway, that concludes our video on example 1. Remember to read the description below for links to workbooklets that relate to this video.